Welcome back. In this video I'll be solving Leetcode problem 2683, neighboring bitwise XOR. So okay, so we have 0 index derived with the bitwise XOR done as derived defined. There's derived defined next one, but this is cycled. So we have some kind of derived. Let's check this example. And each, so bit at 0 is equal to start 0, so start 1. Let's write it on this example, maybe like this. Okay. Okay, so we have something like this, and we are looking for S1, S2, S3, or S0, S1, S2. That's a question. So since we know this is 1, we know something for S0, so if this is 1, that means that this is 1. It means that S0 is equal to, let's say, 0, and S1, I'll write like this, but never mind. So S1 or S0 is 1 and S1 is equal to 0. But since we have XOR, this is weird one. Well, this is always true, so there are only two possible solutions. So depending on this one, we know if S0 is 0 or S0 is 1. Are both, again, it's again 0 or 1. But let's maybe write it more. So in this case, if S0 is 0 and S1 is 1, we know that S2 is equal to 0. And here we know that if S2 is 0, And if S2 is 0, okay, and this makes sense. So if S0 is 0, and here it's other way around. Is that true? So this is 0, yeah. S2 is equal to 1, and if S2, okay. So if there is a solution, there are always two solutions, because if we do XOR, is that true? So if I have 1, let's say 1, 1, 0, 1, that's equal to 1, 0, 0, 0. But if I do the same with 1, 0, 1, 0, I'll get, okay, so, but essentially I just need to start with something. And if I get here or somewhere along the way, because I look back that this has to be something that it can be, then I know it's a mistake. So let's have S0 is equal to 1. And for start and do I need end? So for okay, I think I got it. So for 4-bit in derived, have start Well, what can I tell with that? So start is 1. So let's say I have this situation. Let's remove this. So 1, 1, 0. B should be equal to start and something. And if start was 1, then B is equal to Bitwise start and the beat, because if it's 1, so if let's say start is 1 and and I get the output 1, that means that this has to be 0. So okay, and if this has to be 0 and I have this 1, this is 0 and I have this 1, that means that this has to be 1. and this 0 means that it's self-derived by itself. Okay, and if that's not true, I think I got it. So if I say start is 1, and I have this something, if it's same, then this has to be 0. You start. Let's try to run this. Okay, I think this makes sense. And it works. So this is quite an interesting one. Essentially just have to like simulate what's happening and decide one. I think if I try doing with 0, this also works. Yeah. Okay, great. So essentially idea is that either way, so either way there has to be so starting point is either 0 or 1. If it's 0, we just continue the logic and see what would happen when we loop around, and if we get the same start value, then we know it's good. If not, we know it's false. So interesting one, pretty weird. Let's see, time, complexity, and space complexity. So we use only one variable, that's off n, and time complex off 1, and this is off n because we go for all of them. Okay, I hope this made sense. Thank you for following in this one, and see you in the next one.